Okay, now going through the examples. Which flip to the Okay, so number one, the number of rooms in an apartment and the percent of those apartments. Okay. A, identify the random variable. Okay, so the random variable is the variable that you're looking at. And in this case, it's the number of rooms. Number of rooms in an apartment. Okay, that can be just rooms, family room, kitchen, bedroom, and such. Okay. B, construct a probability histogram. Okay, so we have a histogram. I'm going to try to do it over here. I'm just going to erase this. So histogram. 20, 30, 40. Okay, so this would be the number of rooms in the bottom. Number of rooms. And this is the percent. Okay, so a histogram is very, very similar to a bar graph. Okay, a bar graph has bars but has spaces in between the bars. A histogram has the bars but no spaces in between. Okay, so I'll show you how that works. Okay, so this will be percentage, so 10, 20, 30%, 40, and 50. This is continuous both ways. It's your x-axis, your y-axis. So this would be 1 room, 2, 3, 4, 5, and 6. So to have, well, we don't have any ones, so it'll be 0, which is nothing. So we have 2 rooms in an apartment, and that's 15%. So we're going to draw a bar up to 15%, like such. Okay, then we're going to draw a bar for 3 rooms, so that goes up to 30. So we're going to have a bar up to 30. Sorry, it's not very neat. So bar graph, sorry, histogram. For 4, it's 42. %. For 5 rooms, it's 10%. And for 6, it's 3%. Okay, so this would be a histogram. Okay, so a histogram, all the bars are attached together, whereas a bar graph, they would be separated. Okay, so just to show you a bar graph. So it would look something like this. So it'd be separated. Okay, so bars would be separate, whereas a histogram, they are together. Okay, C, explain the meaning of the individual bars. Well, that's self-explanatory. The bars represent the percentage of each apartment type. So this one is 15%, represents 50% for 50% of apartments have 2 bedrooms, 30% have 3 rooms, not bedroom but rooms, 42% have 5 rooms and such. Okay, so, 4 rooms. So that's the meaning, it's just the percentage, the percent of each apartment type. To describe the distribution, all you have to do is say it starts at 2 bedrooms, it increases until it gets to 4 bedrooms, and then the percentage decreases rapidly after that. Okay, so just talk about the numbers. So it starts at 2 bedrooms, increases up until you hit 4 bedrooms, and then rapidly decreases after that. I keep saying bedrooms, sorry, rooms. Okay, question number 2. Okay, a spinner has 2 equal sections colored red and blue. Make a tree diagram to show the probability distribution for the number of times the spinner lands on blue when it is spun 4 times. Okay, so this is 2 parts to this question here. We have 2 parts. The first part is to make a tree diagram. Okay, and we're going to do the outcomes when it's spun 4 times. Okay, so we start at a dot, we spin it once, we get a, what was the colors? We get a red or we get a blue. Let me make this wider. So that's spin number 1. Then spin number 2, we could have a red or blue, red or blue. And we keep breaking off. Red, blue, red, blue, red, blue, and lastly red and blue. But that's the 3rd spin. Now we have a 4th spin, so we break off again. Red, blue, red, blue, red, blue, and so on. Just gonna change my marker. Okay, so that's the make a tree diagram. So make a tree diagram and show the probability distribution. Okay, so whenever you see this probability distribution here, you have to make a chart. So we're going to create a chart. Always, 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 it's going to be a chart. So the chart represents all the outcomes that we could have. Okay, so the chart should include the number of times the spinner lands on blue when it's spun 4 times. Okay, so we're going to make a chart here. I didn't include a frequency in this one because we're going to have to add them up. So we have our outcome. I'm just going to do frequency here. And then we're going to have our probability. Usually we don't have the frequency, okay? Usually it's just the outcome and the probability. But just so we need to count them. So if you were to spin it, a spinner, 4 times, what are the outcomes on how many times it could land on blue? Okay, well if I spin it 4 times, it's possible I could land on blue once, twice, 3 times, 4 times, or even 0 times. So our outcomes become from 0 all the way up to 4. Because if we spin it, we get 0. We could get blue 0 times. We get it once, twice, 3, or even all 4 times. Okay, so those are our outcomes, and they're here. All our outcomes are here. So I'm just going to count how many blues are in each row. So this one has 0. This one has 1 blue. 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, and 4. Okay, so I'm just counting how many B's I see. 1, 1. Sorry, that one has 2. This one has 1, 2, 2 there, 3 Bs, 1, 2, 2, 3, 2, 3, 3, and 4. Okay, so now we're gonna see the frequency. So how many times it comes up 0? Well, once. How many times is it just one blue? 1, 2, 3, 4 times. How many times does it come up twice? 1, 2, 3, 4, 5, 6. 3 times, 1, 2, 3, 4. And comes up all 4 times is 1 chance. Okay, so that's the frequency. So now the probability. So it'd be out of 5, 11, 15, 16 in total. So if we're afraid to land on blue 0 times, it's a 1 out of 16 chance. Okay, to land on once, it's a 4 out of 16, or a quarter, 6 out of 16. Actually, I'm not going to reduce it here. Just going to stagger it again. 4 out of 16, 6 out of 16, 4 out of 16, and 1 out of 16 shot. Okay. If you want to reduce it, you may. So 1 over 4, 3 over 8, and then 1 over 4. Okay, so this is the probability distribution. It's a chart of all the outcomes versus its probability. Okay, B, calculate the weighted mean. So you're going to pause it there.